Good morning. Chapter 5, Lesson 3 is on page 215. We're going to be multiplying and dividing monomials. Pretty simple stuff. Monomials, remember, are numbers, variables, or products of numbers and variables with whole number exponents. They have to have whole numbers as the exponents. And we remember that monomials that just have numbers, we call those constants, like -8 or something. So let's get started. Here's a little bit review of what we had as far as our formulas for exponents. We have a to the m times a to the n, as long as they're the same same basis. All we do is add the exponents. And if we do the opposite and we divide those, a to the m divided by a to the n, all we have to do is subtract those exponents. One more thing we need to point out is a to the minus m is the same thing as 1 over a to the m, and that's just something that we're going to use constantly, so that's one of the ones that we should probably memorize as much as we can. Let's get started with number 37. We have 16x squared divided by minus 4x squared. Remember, you can always break these up into little pieces because these are really commutative things that we can do that to. So if we check this out, we have x squared divided by x squared. Well, I guess we could just definitely cancel those out. So that's going to be like a 1 over 1. And 16 divided by -4, I think, turns out to be -4. And that turns out to be a 1. So I think our answer for this one turns out to be -4 times 1. And on the denominator, we have 1 times 1, or just plain old -4. Let's move to something a little more complicated, like number 77. We have a whole bunch of stuff here that we've got to figure out. Remember, multiplication is commutative, so we can break everything up. We can move things around if we need to. Multiplication is commutative, so that's exactly what I'm going to do. I'm going to break it all up, so I have QRS times a negative Q times R times S cubed times a -5 times Q to the -3. I'm going to put a parenthesis around that one, times r to the 4th times s to the -5. I'm going to combine everything. I'm going to put q and a negative q and a q to the -3rd power. I got all the q's. Yep. Let's try the r times another r times an r to the 4th. Took care of the r's. Let's check. Times an s times a s cubed times an s to the -5th, and I think there was a constant and even in there, a number 5, -5. I'm going to go back in and highlight these just to remember that we have exponents, a 1, r to the 1st, r to the 1st, s to the 1st. Okay, I think we took care of highlighting all those. So I have q times a negative q times q to the -3, so I have 1 and 1 and a -3. I'm going to add those up. So I think I end up with negative q to the -1. -3 plus 1 is q to the -1 times r to the 6 times s to the 4 minus 1, -1, times a -5. And I'll put that -5 in the front. Remember, everything is just being multiplied. Everything is commutative. So let's rewrite this. -5 q to the -1. You know what I'm going to do is I'm going to change these. -5 times the -1q is a q, so I've got 5q to the -1, r to the 6, s to the -1. And I'm going to go back and use my property up here. A to the -mth power is 1 over a to the m, so if I were to say s to the -1 power, that would be the same as 1 over s to the first power, which would be the same as 1 over s. So I'm going to use that property over here. I'm going to end up with a 5 r to the 6th power in the numerator. That q goes down to the bottom because it's q to the -1, and that s goes down to the bottom as a 1 as well. So my final answer is 5 r to the 6th divided by q times s. Let's make sure I didn't make any mistakes there. I think we are okay. Remember these rules up here at the top. This one that we used today, a to the minus m is equal to 1 over a to the mth. We do that and we should be in great shape. Thanks so much. We'll see everybody out tomorrow.